Well, the sun never sets on DevHeads, right?
Right.
How you guys been?
Doing well.
Yeah, I'm up north right now because it's about 2 degrees hotter than hell in Phoenix. So I decided to run away. But we'll be up here just for the weekend. We got a couple of friends coming up, so that'll be fun. What's new with you, Umesh? Are you getting rained out, flooded out by the monsoon?
Yeah, it's slowed down this week, but it's still raining.
Yeah.
So, yeah. So I hope there would be no power cuts.
Let's hope. Fingers crossed. What's new with you, Ming?
Trying to go through some of those Yocto layers for the Beagle Y board, and seeing if I can get anything built.
Yeah, I was talking to them, and they said that they're having some trouble getting resources on TI to care. So I was like, well, let's see if we can collab. But the other thing, man, I really, this is honest to God, and it's probably just because of the way that I came up in industry. The number of x86 developers, or embedded developers who work on x86 is way, way smaller than I thought. And, I spent a lot of time in PicMig, so I've done a lot of work with companies that are really x86 centric because they're producing, Intel-based computer on modules essentially. But man, when you go out into the wild, you're like, a lot of these developers are already employed at those companies, right? So yeah, it's a scarcity for sure. So
I've only built about 3 or 4 systems on an x86 that are embedded.
Yeah,
it's just not common.
Yeah. Well, I think a lot of the thought process, at least from my perspective, would be sort of the same thing that you get with enterprise and networking developers, where it's like, well, eventually they'll just come down from PC, right? Eventually all these PC developers will, they'll be working. They're like, oh, hey, we're in embedded. But yeah, it appears not. Maybe they're all working at Intel. Who knows? Well, not anymore. Not after the last couple of days.
Yeah. Well, there could be a whole bunch of people on the market now.
Yeah, I know. Geez, man, it's been a bloodbath. So that's never fun. Anyway, so we're a couple of minutes past the top of the hour. We can go ahead and get started. Welcome to DevHeads Office Hours for Friday, August 9th, 2024. Thanks for joining us. I'm Brandon. I am a technology journalist and editor, and I've been doing this for about a year and a half. So I'm glad to be here with all of the fellow DevHeads. I think it's a really big privilege, and I'll pass the torch then to Umesh if you want to introduce yourself.
Hello, everyone. I'm Umesh. I've been building embedded software and hardware from past 10 years. I'm from Pune, India.
Ming, do you want to go next?
So I'm Ming. I've been working in the Linux space for over 30 years now, and playing around in the embedded Linux world for over 15 years.
Zacck, you're up.
Hey everyone, I'm Zacck. I'm based in Cape Town, South Africa, and I've been a software engineer for a bit over a decade now.
Great.
Awesome. Happy to be here.
Cool. I see Joseph there getting ready to join. A couple other new faces potentially, but if you want to say hi, jump in. If you're in the audience, you can always request to join the stage or say hello in the chat, and we will we'll say hello. So anyway, one of the things we wanted to talk about, we're starting this series on essentially embedded software decision making. So that's really going to boil down to bare metal, RTOS, or embedded Linux. So we wanted to start off with bare metal because it's more at the foundation. Everybody at one point or another who's a developer has worked, directly on top of the microcontroller. Most of the time, people are getting started with Arduinos and stuff. So it's not foreign to everybody, but there's a point at which you decide, hey, this system might be easier if we had an RTOS. And today we're going to kick off the series by examining some of those considerations. After that, we'll get into some community questions, some of the opens, what we can do to get 1% better by next week, ask some guests from the community, design tips and resources, and then next steps. So as I hinted at a little bit, how relevant is bare metal MCU firmware today? Even low-cost microcontrollers, you can get a lot of memory compared to the past. You can get high-frequency ones. You have conversations with people sometimes who say, is this even a microcontroller anymore? Would we consider it a microprocessor? And of course, you can find tons of RTOSs out there on the market, free and commercial. Zacck's been doing a great job sort of breaking down Zephyr for us, and that's gaining a lot of popularity. So why do so many pros stick with bare metal, and when should you? So today we're going to compare, bare metal to some of the other approaches and sort of try to give you a guide as to when and where you should use which approach. So really, when we're saying bare metal, we mean no operating system. So you're coding right on top of the silicon. You don't have free RTOS or Zephyr or embedded Linux or any of that in between your application and the processor itself. There was some confusion in when we posted the poll where Zacck called out, well, actually, there are some idiosyncrasies here between HALs, so we can get to that in a minute. But just want to make this distinction because it's an important one, obviously, this discussion and all the ones that follow it. We did a poll, and this poll ran across YouTube, LinkedIn, and of course the DevHeads Discord server, and we had about 53 responses. And this is the breakdown. So it's pretty even. We're not leaning too far in one direction or the other. The distribution of development approaches is pretty similar across the board. So it's going to be interesting to see what people's perspectives and feedback are as we go through this decision-making series. So the first question that comes up when you are, or one of the first questions that comes up when you're starting your development is how to choose the right firmware architecture. And we're going to take it in this direction because we've got to see what you guys have experienced first. We want to ask around, and if you have any experience in building a firmware architecture, we want to hear from you. Umesh, from your perspective, when you were deciding how to go about your system design from the jump, where do you start?
I think it's a good to start with, of course, having a very clear idea what we are building. So let's say some projects are very small, a simple task where you're just dealing with just a one goal, one control system. Let's say, let me just give you a simple example. If somebody wants to build an automatic temperature control soldering iron or something, I mean, this kind of things, you have only one sensor that you want to read or one purpose that you want to, one task that you have to perform. I think if it's very simple application, then of course not to deal with the operating system. So making very clear whether you need OS or you don't need OS. And then the second part is whether what kind of skills you have, right? So some people probably, as you likely mentioned, some people start with Arduino or something. So they start with high level API, a C++. If you have such a situation, maybe they don't want to dive into the low level codes, right? I'm not talking about Arduino IDE. I'm just saying, let's say somebody have started with the hardware abstraction layer straight away. Then they might not want to go into real bare metal, because bare metal again is very, very complex. How deep you want to drill down. Some people could even write assembly code, right? So let's say if you are writing a code for 8-bit microcontroller for a simple task, and if you want to achieve very high performance computing, okay, to strictly time constraint application, it's a small task, but you have a strict timing, then probably somebody will say, okay, the bare metal is maybe C or assembler to write. So I'm not saying that way, but have to have clear understanding as a requirement of the project where you want to dive into operating system or not. So if it's not, then of course the bare metal is the approach to go. And then again, there is one more aspect to that. You will check what kind of middlewares are available. So these days, if you use some kind of abstraction layer, then you have a ready-made middleware because a lot of middleware being supplied by vendors. But again, as I said, if the task is very simple, you better prefer to write your own code, which you have a more control over, right? So you have a code control and then you have a higher efficiency. And then you don't need huge memory again, right? So that way I would choose.
Can you tell me where all those people who write assembly are? Because I've been looking for them.
I think these are the people, at least I would talk about in India where I live, where I can find them. So I find them working with a defense project. So let's say an institute like CDAC, who do a lot of innovation in India, and they are basically older people. So recently I met one lady, she is 51 years old. Now meeting 51 years old computer engineer in India, okay, it's amazing to ask and see how tight time constraint code she write, and then it's amazing discussion with her. So maybe defense, space, maybe healthcare. I mean, this is where you're gonna meet them.
Yeah, I mean, we just recently had a Ask a Developer session with Christoph, who's right, and now we're seeing more and more microcontrollers, like I said at the beginning, that are adding a lot, what we would consider a lot of memory. So, I think it makes it more.
Some sort of filtering on the server yesterday or something, and they needed like something every 1 second or something, and then in addition to that, you need timing constraint, and then you need timing constraints from like more than one place to justify all the effort that you're going to use for putting in an OS. So you have to choose the right time to do it, I think. So I do prefer bare metal, but like if you have interesting problems where you need timing, then the RTOS will be something good, I think. Makes sense.
Yeah, no, totally. And sorry, I was just laughing that Ming was pointing out that all the assembly developers are in retirement villages in the chat. So I don't know. How about you, Ming? I mean, you're at the embedded Linux level. At some point, I'm sure that you're like, okay, well, I'm going to make a decision. I'm just going to stick in the Linux realm. But at some, when you're choosing an architecture, a system architecture, maybe as a consultant, you say, maybe this isn't a good place for embedded Linux. Maybe you're way overshot, right? Does that ever happen?
It does. And I mean, the main project I'm working on now actually is a mixture of, we have a sensor that is running on bare metal, and then we have a hub that is running the embedded Linux that is picking up and talking to the sensor, talking to the cloud. So there's a lot of overlap between things when you're splitting things out to do the real low-level core power, the power efficiency. We had to go bare metal because we don't want it to have any power overheads of running an operating system. So we're looking at battery-based sensor systems. And so we want to be as close to that sensor as possible.
Yeah. Do you find that, I mean, in a lot of your projects where you're doing, multiple approaches, multiple architectures, is that fairly common? I mean, do you find yourself doing bare metal programming as well?
I have been getting into the bare metal just recently over the past few years because of a lot of the embedded Linux sits as that interface between the bare metal and the outside world. Yeah. And there aren't enough resources to deal with what's happening on the bare metal. So I kind of get dragged down into it to help out.
Yeah, that's actually really interesting that I hadn't considered. When you think about, we try to create lines so we can categorize things pretty easily. But like you just pointed out, if you've got an HMI, an industrial control system that's running an HMI, you're probably going to be running Linux or some flavor of Linux. And then everything else about the system, especially now that these systems that like the SOCs are getting so powerful, you can do a lot with that SOC. So on one place, you may be running Linux to support your HMI, but you may be doing some control somewhere else, right? And that's an interesting sort of paradigm where you may have the need to, take multiple approaches in the same system architecture. So that's cool. Umesh, do you have? I think you were telling me about a story that you had way back when you had to essentially pick up a project where somebody else left off. Do you want to share that with the group?
Yeah, so I want to share with everyone the story. Like as a consultant, you always get a project from the client which the project has given to somebody, and then somebody couldn't able to finish the project, and then the project comes to you. And what happens is very often this client comes with you with the source code that they have paid somebody else to write the code. Now, one of a situation where the task was very simple, have to get the data out of this, let's say just from the device, from the sensor. And this guy, when I looked at the code, I saw that guy was trying to port the RTOS just to get the sensor data and process. And the task was very simple. So I asked this question, like, who wrote this firmware? Then they say, okay, we hired somebody because we thought maybe we will build in-house team, and then we will get written the code from that person. And that person probably as a beginner, maybe not so expert, who want to jump into embedded. So he tried to port the RTOS, wherein it does an interrupt-driven approach you can follow and can be done. So then I found out this guy paid a huge money for that development, and then it came to me, and then that guy was saying me, okay, you just improve this code, right? Fix this code. I said I have to write that everybody, whoever working with the embedded system, understand what they are building, and then they figure out whether they really need operating system or not. Here, I want to make it very clear. Like if you want to go with an approach of operating system like embedded Linux or something, that cannot be compared with any other bare metal or something, because that approach is completely different. Yeah.
While you were talking, I was thinking about the fact that you have FreeRTOS, you have Zephyr, you've got communities around them, and then you have a lot of examples and demos and drivers and all of this stuff that's like right here. When you look at it, you're like, oh, it's all here already, right? And when you get into bare metal programming, that's not necessarily the case, right? I mean, you're coming into something that's custom, and so when you need help, it's like, well, where do I even go, right? Well, I mean, if you come to DevHeads, but like, where do I turn now? And if you are new to a situation, you're probably going to say, I'm going to go where I know that there are resources. And so you're going to pick, a community, an RTOS, an ecosystem, a place where there's already a lot of that available. And that could lead you down a dangerous path or an unnecessary path. The traditional embedded developer, like you were saying, all of the 50-plus-year-old, programmer that from India, the code optimization was because you were trying to get into a very tiny amount of memory, and a lot of that had to do with cost constraints. That's sort of a good segue into one of the next slides, going into application requirements. Obviously, the thing that's going to dictate which way you go is going to be what your application requirements are. So I don't know, Umesh, when you start a project, how do you go about defining application requirements and then using that information to make your decision about your?
I think the most important part I feel when I evaluate any application is the time. How much time I have to develop the application. Okay, because this is directly related to the point that you made. With the bare metal, you don't have any middleware or libraries or something written, right? So sometimes it's possible maybe the task looks very simple in the beginning, but it's not actually the cases. So I first look at the time, how much time I have to develop, because sometimes it's possible, like if you use OS layer or something where you have a middleware or something which pre-exists, you can quickly port it to the microcontroller, and not everywhere you will going to uh, have a memory issues, right? So again, you look for that, how much time you have, then whether you want to run over batteries, what are your power constraint, how much memory that you have on your target microcontroller that you have chosen for the application. And I think, again, as likely mentioned on a slide itself, the skill level is very important. I don't want to, let's say, if I have to write the code myself, if I don't write so much high level APIs, I don't dive into that. And if I have to hand over to somebody else in my team, some engineer who deal with the high level APIs, I don't want him to waste his time to learn and dig into low level programming. I don't want them to read maybe C or maybe assembler or something when they are very good at C++ or something, right? Some middleware which exists in is available in C++ or something. So I think this way I evaluate whether my application really need and what are my constraints in a project.
How about you, Zacck? What are your steps? What's the progression when you're looking at here are my application requirements and then translating those into need?
So I come from originally I come from like a mobile and like a very low resource device code. Like when you're speaking about like J2ME devices or feature phone devices, I come from, you have to consider every bit of memory. You have to like uh, minimize as much as possible. So what I'm trying to do is I'm trying to pick out what is the quickest way. It's the quickest way I can do this in like the cheapest manner. Like you don't need a Raspberry Pi if you're gonna read two lights and report on something of the sort. You see, and then you see what's the smallest platform you can do this on, and then it depends on, again, it comes back to the end, it comes to the skill level. Like I'm going to most likely choose something from SD or from ARM because I'm familiar with what I'm walking into. So it will also depend on what I'm familiar with. Sometimes clients come to you and they already have a device and you need to do something on that device. Then you kind of work with what they have. And I think this is going to be a new problem for Zephyr because Zephyr has this HAL that makes you be able to do things just by itself. So a lot of people are going to end up using Zephyr because it's so easy to do things. I don't know. Makes sense.
That's right. No, yeah, and that's the problem we've talked about a lot when you get into these situations, right? Is like Umesh was describing in his story, is you get people who are doing things because they're either easier or they think they have resources, and then they get into a system design that requires something different, and they're lost, right? They don't know what to do. That's like when we were talking about it in the server, starting from the linker scripts up. It's like, why would anybody do that? Well, it's like, well, because you might run into a situation where you need to understand things at that level. But if you've just gone in on Zephyr and had all of this abstraction, you get into this program or this project, right? And you can get lost really quickly. One of the things that I keep laughing at is that the hardware guys, Hamel and Joseph, keep going off camera. They're like, oh, we don't need to Hamel, from your perspective, how much firmware do you have to deal with, on a day-to-day basis in your job?
I used to write firmware about 6-7 years ago, but then I completely moved to like just and firmware. I can help with the firmware guys and like in some high level architecture on how things should be. And circling back to what Umesh said earlier, it's like if if you have a hammer, everything looks like a nail. So if you just have one skill, if you just know Zephyr, if you just know RTOS, you would try to fit in your project to to use that. And on hardware also, it's true. For example, if you know Arduino and its capabilities, so you will try to, if you get a new project, you will try to fit into how can I fit this into an Arduino style thing, regardless of whether it fits the bill or not. So that is a mistake that people usually make, especially when they are coming in the early careers. Is like the first thing that they are familiar with, they don't want to go out and explore other controllers or other technologies and embedded and stuff. So yeah, I think you need to be open to use new technologies and use the right tool for the project and do justice to the project.
Great, thanks for that. Joseph, do you have anything to add from your perspective? What's your involvement in firmware, in your day-to-day as a hardware engineer?
Okay, so I don't do much of firmware in development actually quite now, so it's been long. It's over 2-3 years. I've not been really involved in firmware, but based on my little experience designing hardware and collaborating with other developers, I say during it depends on the application, using OS or non-OS like bare metal. Most times for simple scale, for simple designs, we do tend to use like the Arduino IDE, just running everything at the stretch using libraries and running our development. Yeah, but when it comes to a large product that we need to move into the market, okay, like for instance, right now we are actually building an OBD device, enabled device that has a GPS in it. So I'm actually trying to leverage if it will be proper for us to like write our bare metal code from scratch, or using just doing everything using the ESP IDF. We are using the ESP IDF for development. So we are contemplating, do we do our write the bare metal from scratch, or should we use the ESP IDF and the drivers that are available? So based on that, is we're actually looking at the time constraints again. So we need to get something running at as quick as possible. So we decided to use like the IDF and the drivers available. So in my own case, I would say using OS should be in a more complicated and sophisticated application. So if you have a simple application, you can easily use your libraries and other stuff. Yeah.
Thanks, man. Ming, so you were just talking about an application where you're using both Linux and bare metal, and you've got to hit some certain power requirements. At the that it seems like a complex system. So when
Yes.
when you are going about defining, how much memory do we need, right? Okay, here's the system that we're trying to build. It's a plane, or it's a whatever it is. How do you even tackle application requirements for a system that complex, or is it even just is somebody else doing that for you?
To an extent, there's also the concept of, within this particular project, it's more along the lines of, here's the hardware that has already been created, fit the application into it. So you don't always get the choice. Sometimes the choice is presented.
Your requirements are make it work. It's like,
Yeah. We've already plowed however many million into actually creating this prototype design. Can you get it to work now?
Right. Oh, that's awesome. I'm curious for the software firmware guys, how often does that happen? You know, how often are you being brought in? You know, Umesh described a situation where, you know, he was coming in after the fact. Ming just talked about how, you know, okay, well, here we are, here's our system, now make it work, right? How often is that the case versus, you know, blank sheet?
I'm going to say for me, just about every project I deal with coming in as a consultant is, right, so we've got all this history. Now you need to actually turn it into reality. Bye.
Umesh or Zacck? Well, Umesh is taking a drink.
Greenfield is very rare. It's extremely rare that you get to start stuff from the ground up. You usually have to maintain something that exists or improve something that exists. So it's very often that you walk in and there's already systems in place that you have to modify.
Umesh?
So right now, if you ask me, I don't get this kind of customers anymore, because the story that I shared is when I used to take this consulting projects. Right now, I'm just focused on one automation product that solve one problem. So thank God I'm get out of it. It's just every project is different, every customer is different. It's too painful. Yeah.
So when you go down the checklist, just to round out this section, Umesh, you know, the places you hit, okay, look, I got to decide whether or not I'm going to choose, bare metal, you know, HAL, RTOS, something else. You go, let's look at the power consumption. Let's look at the memory constraints we have. And then, of course, let's look at whether or not we know how to do this damn thing at all. What else?
Yeah.
Are there any other key considerations you need to make?
Yeah, how much time we have and how much it would gonna cost, right? Because memory is directly proportional to the cost very often. So
yeah, which is the next slide. So cost considerations. Obviously, you know, it used to be, and it still in some cases is, that the memory was ended up being the most expensive part of the system. I'm not sure how much that actually remains the case in the same way that it used to, right? You know, it's the microcontrollers are advancing to a point, like I said, that they're pretty advanced. They've got a lot of resources there. But, you know, you end up in a situation like Ming was describing, or like Umesh was describing, where, you know, you're already halfway through the system and the system's already defined, right? So it's like, make it work within this context. You may not actually have much of an impact on this parameter. But I don't know. Do you have anything to add here, Umesh?
yeah, I think apart from the cost of a memory, I mean, overall the cost of development of an embedded systems is basically another layer. If you try to put the operating system on the top of it, you probably end up then having a decision whether you are going with the free RTOS that's available, or maybe if it's a paid. And then one more cost maybe added to that is if you are using even the abstraction layer approach or IP core that you want to license from somebody, let's say some IP core or some interface that you want to integrate in your project, and you don't want to develop that from scratch, because I understand from my colleagues that the bare metal is probably not for everything, because probably some interfaces to write maybe takes 1 year to understand the whole technology, right? So if you're working with very core technology and writing firmware from scratch, it's no fun, right? It's very painful. So very often we go and license the IP core, or maybe get some ready libraries from somebody, and that cost will get added on the top of that. So we have to also make sure how are we gonna see the cost, because as much as layer you start putting on the top of memory, that add to the cost of the product, whether
Yeah,
it's a
that's
middleware.
actually,
If it's
yeah,
not even an operating system, even the middleware, maybe sometimes you have to license from some companies.
yeah. That's actually a really good point. That's interesting. Jack, from your perspective, you know, when you get into, if you could do compare and contrast here, when you get into a bare metal, you know, firmware based project versus an RTOS or an operating system based project, what's the time usually? Like, are you like, okay, well, this is going to be this much more complex. I'm probably going to have to project out, X more amount of time if it were the same thing, right, or similar as possible. Are you looking at, more layers of complexity equaling more time, equaling more development costs?
Yes, yes. I think one thing we forgot out of this discussion is because if the time increase, you have to pay higher salaries to the developers, right? Because that's also cost that been added apart from the cost of a controller and memory. We just forgot this. Engineers are very expensive these days. So
Mhm.
yeah, I mean, if you do bare metal, and then if let's say somebody says in the chat like these people are old and they are there, but I have seen some old folks who do very low level and very time critical development. They're very expensive. They charge a lot. You will not even get their appointments, even if they have to maintain a legacy code, right? So I think good point. This development time will be added as a cost of the development.
Zacck?
Mm, I tend to agree that development time will be a factor of the cost, but then also, um, how do I put it? Like when you have to think about ownership of this thing. So how if you have like you're flipping switches basically, and you don't need such tight control, then like using existing code or something of the sort, then it's cool. But if you have like very you have like demanding requirements, and you need to maintain those requirements over a long time, and let's say the way you're using a protocol changes, and you've just gone and said, RTOS or HAL, send this data for me and pull that data for me. And then the way you need that data, as often is the case with RTOS stuff, the way you need it or the way you need to consume it changes just by a little bit, that you can't use the thing that you were using before. Then now ownership, like how are you going to maintain this? Are you going to go back and charge your client like you're starting afresh because you have to build the thing up again? Like you have to consider the I've gotten the project, I'm going to deliver the project, now what? That part of the project as well when you're considering development time. I don't know if I put myself very clearly.
Yeah, I think I understand what you're saying. Is when you got to look at the whole project when you start, right, from the beginning, and what the implications are. Because if you get yourself into a point, you don't want to design yourself into a corner, right? Basically, because that could, that could end up being very expensive. Okay, cool. Let's move right along. All right, now. This is actually a really interesting thing, and one of the last sessions or slides that we'll have before we start wrapping up. But it's security. Okay, we talk about the security of IoT devices in particular, which is where we're trying to focus on in DevHeads. Is if you have there's a lot of debate back and forth about whether or not open source is secure than something that's closed source. There's also a lot of debate about, well, not much debate about this. The more code you have in a system, the more vulnerabilities are going to be necessarily, right? So in a weird sort of twist of fate, you could have this this code that is developed, this firmware that's developed by one or two people. That's not a whole lot, many lines of code, but it is robust, and there aren't a lot of holes in it compared to pulling in an operating system plus a bunch of middleware, and you got this software bill of materials all of a sudden that's bloated, and you don't really know what's inside of your stack. So in terms of firmware security, there are some opportunities to make a more secure system when you're doing bare metal. Umesh, you want to comment on that?
This is very interesting point. Let's say, so here I want to distinguish, like if you're building a core embedded products or the IoT products? Because I have a little bit of slightly different opinion here. So let's say if I'm building an IoT, which is a pure IoT product that has to connect to a cloud or server, then I always prefer to go with a middleware, some sort of API to be used rather than a bare metal approach. And then the other aspect to look at that, securing the firmware on the hardware side, you also need to have a good amount of memory to hold the security certificates. I mean, so I wonder like what other people think, but to securing the firmware, I'm not sure apart from at the firmware level security just for embedded, because here some products are core embedded product, that's where you would go with the bare metal if you just have one task to perform, like a simple application. Of course, high level, even if it's a core embedded product. So I think I distinguish these things first when I work on any project, whether it's a core embedded and what are the expectation and other things. Because again, you see some cloud services like Amazon, AWS, say for example, they give you root CS certificates, and then there will be some certificate and primary private key that you have to put inside your firmware. So it will take the memory of your microcontroller, flash memory of the microcontroller to store, right? So, I mean, considering that whole thing, I would, in that case, use a 32-bit controller and use API. And if it's a core embedded, then go with the bare metal. That's how I would say I choose.
I think one of the things you brought up here, Ming commented about goes back to cost. There's one thing on here about certification, right? If you have enough memory, right, to be able to support, certificates and the encryption, modern encryption, the bare metal approach is probably going to save you a lot of money depending on what you're building. Because if you're going into a regulated, if you're building a regulated system, right, that needs to be certified, and you've got to go through testing, they're going to check it. You got to check every single line of code, and you can write bare metal programs that are a few dozen lines, right? It doesn't have to be an overwhelming amount. But as soon as you start getting operating systems involved, that expands exponentially, and in a lot of cases it's safety critical. You're going to have to recertify every time you change the system at all, right? So that can add up really quickly. And then Ming made this point that back in the day, people would buy the server and get him for free, and now they buy him and they get the hardware for free. But all of these things are really interesting considerations in terms of the cost of a system. And I think besides really having the skills, but I think a lot of this boils down to that, right? What's the time, what's the overall cost going to be if you have the skills to do one or the other. On the security front, Ming, you have anything to add?
Yeah, I was going to say, because I'm working in the medical industry now, so highly regulated, and one of the key things there is right from our initial design, we had to be looking at HIPAA compliance. We had to be looking at, this is medical data. So as such, it needs to be encrypted right from the point of collection. So even though we've got a bare metal for our sensor, we've got to make sure that there's enough power, there's enough resource on that to ensure that we're maintaining the security, because that is something that if we lost the security, we don't have a business. So the cost of not putting in proper security is no business.
Right. Yeah. No, that's a great point. Are you so man, if you're in the medical industry, are you certified? Is your system certified? Does it have to be certified?
Yep.
Oh wow. So that is probably
I had to go through the complete FDA clearance of every single component.
Wow. Yeah.
That was fun.
Yeah. So, if you think about what that's like on embedded Linux versus what that could potentially be like, with bare metal, You know, just I'll let your imagination do the thinking there. Awesome. Anybody else have anything they want to add about firmware security here? Any thoughts or suggestions? Navadeep put in the chat. There are these dedicated security ICs that companies like Microchip, I think Infineon has some of them too, are essentially like discrete, you know, security accelerators, right? So you just use them to, you know, run your encryption algorithms, and then you can store your keys and certificates and all that stuff in there. They essentially work as a root of trust. So if you're more on the system architecture side, that's something that you should definitely take a look at, because it could give you some flexibility in your design potentially. Thanks for sharing that, Navadeep. Especially from a development standpoint, it can make things simpler. That's for sure. All right. So that was it on bare metal. So next week we'll get into you know, some discussion about RTOS. You know, how do you know when you need them, and once you do, where do you start? So any last thoughts on you know, using bare metal? You know, when's a good time to do it, when's not? You know, any thoughts, any horror stories, tips, tricks, or experience anybody wants to share? We'll go back so we're not confused. Anything?
There's a time and place for both of them, I guess.
That's right.
That's right.
Okay, cool. So community question. So we've stepped away from this for a little bit, and time to bring it back into the fold. So here are some opens that we got. Some on one of the reasons I've been looking for x86 dev is that Marvy keeps asking these questions about you know, Intel-based designs, and I'm trying to figure out if there's a way I can help them. So looks like I'll do some reaching outside of the server and bring in some friends that I know. So we'll try and get those addressed. A bunch of stuff is now creeping in around Zephyr. So you know, there's some on an AppMega, and then another one you know, on an STM32. So I expect to see more of that in the coming days, weeks, and months. So if you've got any experience with Zephyr, might want to check that out. Edge networking, a couple of different things there, and then you know, we've got a smattering of other questions too. So if you have the time and the desire, you could jump in there and help out your fellow dev heads. We appreciate it. So coming up, office hours the next few weeks. Are you ready for RTOS? So now it's time for embedded Linux, and then after that we'll have a little bit of a roundtable and throw some applications at some of our experts and see what they'd use in what situation between bare metal, RTOS, and Linux. That should be fun. And then after that, we're going to get into an IoT product development lifecycle series. We did a session on that a few weeks ago, and I realized that this was a perfect topic to spread out over, you know, a couple of months, even, where we break down each phase of the development lifecycle, bring somebody in who's with it, and then give some best practices, tips, and tricks. The next engineering hour is actually this coming Sunday in 2 days. It's going to be building on a lot of the stuff that Umesh has done over the last few weeks with interrupts and multiple interrupts and understanding priority levels. Except this time, Edison's going to be taking the baton, and he's going to be looking at how to implement multiple ADCs on the Cortex architecture. Most of the stuff that we've been doing to this point has been on Cortex-M. So that is pretty cool. That is going to flow into Systic Timer for the foundation of RTOS, and then we'll start moving more and more into real-time operating system topics as we go. So more DevHeads demos. I said that there was some memory stuff on the YouTube channel with Christoph. You might want to check that out. And then we've got a few more that are coming up in the coming weeks. So keep your eyes peeled for that. And then 1% better by next week. Any suggestions? Anything that anybody has? I have a question for those of you who. So a while ago, Hemel shared a format in the server of getting started. We've had a lot of back and forth over the last year about what the best way to handle an intro and welcome page is in the server. Because one of the things that happened early on was we had this general chat, and people were jumping into the chat saying, "Hi, I'm so-and-so," right? And like there would be discussions going on, and then these people introducing themselves would just completely like disrupt it. So we put it away over in another section, and what ended up happening was that the discussion started getting split into, people would start introducing themselves there and then having discussions off in this, separate environment. So we played around with it and ultimately came to sort of a halfway decision that we would just, have a welcome page that says, "Hey, welcome to the server," and then people could introduce themselves in the chat and we would just deal with it. Hemel introduced this other server that has a template that's basically like, start here, you get a welcome, and then there's a place that's highly moderated, it looks like, that says put your introduction in, and that's it. Like nothing else happens. I think that's great. The question that I have for all you guys is, would that result in having too many channels? And it would also push a lot of the channels on the left down, so they're just further down. And I wonder if you guys have any thoughts on how to approach that, or if you would have a preference or you don't care. You guys are all already in the server, so it's kind of like you don't need to welcome or introduce yourselves. All right.
Right.
Okay. I think we can do it like that, as Herman said. We can just create a specified channel for the introduction, and once the introduction is being put in place, then we close it for that particular person. It will reduce the interruption that goes on in the general chat during when chat is going on and all that. So it's a nice idea. So for the increment in server channels, I don't think that is actually much of an issue, because there are still more channels in each server. It is just for a specific reason. So we can do with that.
Okay. Cool. Thanks for your input. Were you going to say something, Umesh?
For me, I think what's happening right now is good enough for me. I don't see any issue, because when somebody join it for the first time, they are confused. People are shy, right? So don't want to post. And then when they say it's a general, so everybody feel free, comfortable, and then we can redirect them where they should put more technical question. Because in the beginning, not everybody is opening up. So for me, what's happening right now is not bad. But yeah.
Okay. Actually, there's a good that brings up a good point that I should have mentioned as well, which is, before we were trying to be really cute, and we were like, you could go through the onboarding process and see different, only see certain channels, and not see others if you didn't want to. That ended up, I feel like that just ended up adding unnecessary layers of complexity. So we basically just blew out the, now everybody can see everything if they want to. One thing about Discord that's weird is that in the upper left, it will start suggesting channels and discussions to you automatically, even if you don't want it to. So in the upper left, there's a place where it says browse channels, and you can go in there and click show all channels. If you do that, everything will be available to you, and you'll be able to see all of the different places where there's activity happening. But yeah, that was a change that we made recently, and I think that reduces some of the confusion that I think people were having. And the reason I bring this up really is just, when people get in, how do we get more people active and engaged in the server? That's basically what. Yep.
Keeping it simple, I think I prefer to keep things very, very simple. So people will open up, and then post something. And from there, as they spend more time, I think then they probably would be more willing to do what you say. If you give them first a list, then they say, okay, maybe it's very you have to follow fixed set of rules, and we will say, okay, thank you very much.
I missed a comment over here in the chat. 32-bit Savior says that he works in the payment industry, building payment pin pad terminals, and they're obviously that's has to be a very secure system, and they always have to do PCI DSS. 32-bit. Are you doing everything? I'm assuming most of your work is bare metal. You want to throw it in the chat or say what's up? Oh, Marvin. Sorry. Marvin. I don't know if you're there, but I'm going to take this conversation into the server. He's typing right now because we're almost out of time, but yeah. So anyway, that is it. Everybody, thanks for bringing your grain of sand. Marvin, if you get your comment in there in the next 15 seconds, I'll read it. But if not, we can just talk about it in the chat. I really want to thank everybody. Honestly, I feel like it's a pleasure to be able to spend an hour with you guys every Friday. And other than that, next meeting is a week from today, 8/16. Thanks for being a dev head. And let's see if Marvin... Oh, they work on top of embedded Linux. Well, you and Ming should go have a coffee or something. So anyway, thanks all for your time. Really appreciate it. And we will see you in the server. Have a good weekend.